Hi, in this tutorial, we're going to go over solving linear inequalities. So today, you'll learn how to graph the solutions of an inequality on a number line, how to use interval notation. You'll learn how to understand properties used to solve linear inequalities. You'll learn how to solve linear inequalities, how to identify inequalities with no solution or true for all real numbers, and how to solve problems using linear inequalities. So solving an inequality is the process of finding the set of numbers or solutions that will make the inequality a true statement. So a linear inequality in one variable has the form ax plus b is less than c, ax plus b is less than or equal to c, ax plus b is greater than c, and ax plus b is greater than or equal to c. So here's an example of a linear inequality. 3x plus 6 is greater than 12. So here's how to graph solutions to linear inequalities on a number line. The first thing you're going to do is shade all points representing numbers that are solutions. You're going to use square brackets to indicate endpoints that are solutions, or use parentheses to indicate endpoints that are not solutions. So let's do an example. Let's graph the solution of x is less than 4. So if we have our number line, and we're going to graph x is less than 4, so that means that x would go in this direction. And to show that 4 is not included, we're going to use a parentheses. Now let's graph the solutions. -2 is less than x, and x is less than or equal to 1. So let's draw our number line. Well, it's saying that -2 is less than x, or x is greater than -2. So we know x is greater than -2, but x is less than 1. So that means we go up to 1. So now to show that 1 is included because it's less than or equal to 1, we write a bracket sign. Now solutions of inequalities can be expressed in interval notation or set builder notation. So here, x is greater than b. So we can see that x is going in this direction. It's greater than b, but does not include b. So in interval notation, we have b and all the numbers which are greater than b. And we use the infinity symbol to show that it goes in this direction indefinitely. Now in set builder notation, we write curly braces x, a line x is greater than b. And the way you read this is the set of all x such that x is greater than b. So now here we have x is less than or equal to a. So here we know x is going in this direction, but also includes a. So the way we write this interval notation is negative infinity, because x is going in this direction, a, and because it includes a, we write a bracket sign. So now in set builder notation, we have the set of, by the curly braces, all x, such that with this line, x is greater than a. So let's do an example. Express the solution set in interval notation and graph the interval x is less than or equal to 1. So here, have our number line. So we know x is less than 1. So that means it's going in this direction. And x is less than but equal to 1. So that means we can use this bracket sign. So the way we write this in interval notation is negative infinity, because x is going in this direction, 1, and we use a bracket sign because it also includes 1. Now let's express the solution set in interval notation and graph the interval x is greater than negative 2. So let's draw our number line. So now we know x is greater than negative 2. So that means x goes in this direction. But we know x does not include negative 2. So we use the parenthesis sign. So to write this in interval notation is parentheses negative 2, comma, infinity, because x is going in this direction, parentheses. Now let's go over the properties used to solve linear inequalities. The addition property of inequality states that adding or subtracting the same number to both sides of an inequality does not change the solutions. So let's do an example. Let's solve x plus 3 is greater than 8. So here we have x plus 3 is greater than 8. So we can move 3 to the other side by subtracting 3, so that we get x is less than 8 minus 3, or x is less than 5. Now, the positive multiplication property of an inequality states that multiplying or dividing both sides of an inequality by the same positive number does not change the solutions. So let's do an example. Here we have x over 6 is greater than or equal to 5. So we can isolate x on one side of the equation by multiplying 6 by both sides. So now we get x is greater than or equal to 5 times 6, or x is greater than or equal to 30. Now, the negative multiplication property of inequality states that multiplying or dividing both sides of an inequality by the same negative number and reversing the direction of the inequality sign does not change the solutions. So let's do an example. So let's solve negative 3x is less than or equal to 12. So now, because we're dividing by a -3 to isolate x on one side, we're going to reverse the direction of the inequality. So now we have x is greater than or equal to 12 divided by -3. Or x is greater than or negative or equal to -4. So that's our answer. Notice how we reversed the direction of the sign from less than to greater than. So here's how to solve a linear inequality. The first thing you're going to do is simplify the algebraic expression on each side. Then you're going to use the addition property of inequality to collect all the variable terms on one side and all the constant terms on the other side. Then you're going to use the multiplication property of inequality to isolate the variable and solve the equation. Now, when both multiplying or dividing by a negative number, you're going to reverse the direction of the inequality symbol. So you're going to flip them. And then you're going to express the solution set in interval or set builder notation and graph the set on a number line. So let's do an example. Let's solve x plus 4 is greater than or equal to 6x minus 12. So we have x plus 4 is greater than or equal to 6x minus 12. So the first thing we can do is move 12 to the other side of the equation by adding 12. So we get x plus 4 plus 12 is greater than or equal to 6x. Now we can move x to the other side by subtracting x. So now we have 4 plus 12 is greater than or equal to 6x minus x. So 4 plus 12 is 16, greater than or equal to 6x minus x is 5x. So now we can isolate 5 on both sides of the equation by dividing by 5, so that we get x and 16 divided by 5. So we have 16 divided by 5 is greater than or equal to x. Now, 16 divided by 5 is the same as 3 and 1/5 is greater than or equal to x. So now we can write this on a number line. Or we can graph this on a number line. Oops. So x is less than, we can also rewrite this by saying x is less than or equal to 3 and 1/5. Let's add another number here, 4. So x will go in this direction. And because it also includes 1/5, we would use a bracket sign. Now in set builder notation, we would have 3 and 1/5. It also includes that we would use the bracket sign and infinity. And in set builder notation, it would be curly brace x is the set of all x such that x is less than or equal to 3 and 1/5. Now you should be able to graph the solutions of an inequality on a number line. You should be able to use interval notation you should be able to understand the properties used to solve linear inequalities. You should be able to solve linear inequalities. You should be able to identify inequalities with no solutions or true for all real numbers, and you should be able to solve problems using linear inequalities. So now try and solve the problems in the Solving Linear Inequalities workbook. For more help, sign up for our online tutoring, and in the next tutorial, we're going to go over graphing linear equations into variables.